Okay, when you guys go to the spring industrial semester, you click in here, you're going to find all the 3 classes that your friend Chad is going to teach you. Right now, there will be 5. Everybody understand there will be 5. Now we're just focusing on the industrial project. There will be 2 classes for the estimating and the project management. I did not put them in so it doesn't confuse you. These are going to come the last 6 weeks of the quarter. Everybody understand how that's going to go? You guys are going to have 5 classes with me. 3 of them the first 12 weeks, 2 of them the last 6 weeks. Everybody's okay with that? So the last 2 weeks, I don't have him here because I don't want to confuse you. I don't want to put stuff that's not going to be used until 6 weeks from now. Cool? So I'm going to start first with the theory. If you guys go to 222, you're going to have the syllabi. You guys have the syllabi in front of you. So do me a favor. I'm going to, right here, I'm going to be putting my lectures. When I put my lectures like I have done before, I'm going to mount my lectures right here for you guys. For the time being, I'm going to go over my syllabi. So do me a favor. Go to the 4th page almost. I'm going to start with the one that says ECDM Industrial Project Theory 2220. So let me just walk you guys through this class. Can you guys give me a thumbs up when everybody's there? You should have this one, hard copy and electronic. This is right in the front of you. Okay, the same instructor that taught you guys in the fall, the good, the bad, and the ugly still standing in front of you. You have no choice. You're stuck with your friend Chad for 1 more year. So if you like what we have done, you're going to enjoy. If you don't, I don't know what I'm going to tell you guys. The good news is Gary Ryman's going to be covering for me a couple of classes here for you. So if I'm out, but for 99.9% of the time, you're stuck with Chad for 18 weeks. Okay, so here's what we're going to do, guys. I'm teaching you the classes right here. It's this class, oops, here's mistake number 1. This class should be, wow, this should be, does you say that one, guys? This should be 11 to 12.
Your office.
Oh, that's my office. Oh, Chad, that's not a mistake. Thank you. That's my office. If you guys like we have done in the past, if you guys want to talk to me after the class is the best way to get in touch with me. The class is going to go from today, January 7th, all the way to April 5th. Everybody can see where the class is going to end. The class, Joe, start at 7:30 to 8:25. And if you guys not here, I hate to say it, but I will give an incomplete. Please don't. This time I will restrict to my gun. So please, 8:30 means 8:30. If you're not here at 8:30, many times, I mean 7:30, I will give an incomplete. So please don't put me in this situation. Monday through Friday, Red 10 where we are. All your information, Mr. Who am I going to pick on? Brian, my friend, all the info, how am I going to grade it is already on my Dunwoody. If you go to my Dunwoody, guys, it's already set up for you. Okay, what is this class? This is Industrial Design Theory. This class, guys, is going to go over the code requirement for an industrial project. You're looking at this book, is the textbook that I'm using. I expect you guys to get this book ASP. It's downstairs. As soon as you can, grab this book. This book has, I think, 21 chapters, if I remember right. And we're going to go 20 chapters. It has 20 chapters. I'm going to go over that. So we have 20 chapters out of this book. 99.9% of it is code requirement for industrial building. Cool. So we'll talk about the code requirement for industrial building. It's 3 credits. The requirement is right here. Here's what we are hoping, guys. You can the textbook. I have the textbook for you right in here. Is it $75? Anybody bought it downstairs? That's what I
just checked online. It's $100 downstairs.
Is it? Oh, okay, so my numbers are a little bit off here. Sorry. So it is the 14th edition, though. I would like you guys to get the 14th edition. 14th edition, like it says. With it, my friend, we need the NEC code book. So make sure you also have the NEC code book, which you all do. But I would like you guys to get this book. Cool. We go over the core abilities, apply math and so forth that the college wants you to learn. We went over this last time. The outcomes of this class, guys, we have program outcomes that I like to always highlight. This is basically site and network code. for electrical project, design electrical system for building, manage electrical construction and engineering projects. So basically, this particular class in particular is about code requirement for industrial project, really. Here's what you're supposed to learn. These are 19 things that you're supposed to learn. Number one, you can see explain. So what we do, guys, summarize it. We go over the service, the feeders and the branch circuits requirement for an industrial building, which is identical to, or almost identical to requirement for commercial building. So we really repeat a lot of stuff here, but we go in depth. Instead of dealing with 600 amp panel, now the size of the building that we're going to be dealing with is 4,000 amp. So you can imagine a 4,000 amp and a 1,200 amp panels, bigger sizes. We focus a lot on grounding and bonding with them. But these are basically the same thing that we guys going to be doing. Service conductor, for the first time, we introduce you guys to the UPS and PDUs. We haven't done UPS and PDUs before. So we talk about this one. Bus ducts, we introduce you a lot to our bus ducts, 208, 120, 480, 277. So these are kind of the highlight of the system. We go over the lighting, security, fire alarm, paging, phone and data, and master clock system requirement for an industrial building. These are the project, the system that you guys are going to install for this building. So we go over how do you install it in this class. NEC requirement all the time. Grounding and bonding. I'm going to spend a lot of time, guys, about grounding and bonding. I know Adam or some of you guys, we didn't focus too much on grounding and bonding. I do have a couple of lectures strictly about grounding and bonding. Equipment grounding conductor, grounding electrical conductor, main bonding jumper, system bonding jumper, supply side bonding jumper. Everything you need to know about grounding and bonding a 4,000 amp 480 277 system, it's going to be in this class.
The sheet that we've got is different from that.
Are you looking at the same 2220? Yeah, maybe because there's three of them. Go to the one that says 2220. Sorry, Aaron, everybody's at that one, 2220? Yeah, this is the theory, 2220, okay? All right, now we're in sync. Sorry, bud. Yeah, the first one is the project. Yeah, it's a ECDM 2220. Yeah, I'm skipping the project a little bit. Okay, we'll talk about harmonic hazardous location, guys. There's a couple of lectures about hazardous location, class 1, 2, and 3. We'll talk about it. Analyze commercial plan. So these basically the highlight, overcome protection device sizing. We're going to follow, like I said, 20 chapters in this book and go over the requirement, which is very simple, very nice little book that lead us through this the project. Assessment. Here's what I did. This is, if you guys remember what we did in the fall, no change. What I do with my classes, I sync them all year. So no switching gears halfway through. You're finished with me. If you guys remember, we did 4 tests, 12.5% of your final grade. We have classroom engagement 10. We have homework 10. We have final exam 30 and a total of 100. This, what you're looking at right now, is on the network and my dot Dunwoody. If you go there, you're going to see the same thing. Cool. Can I have thumbs up, Chad? We fully understand that one. Cool. Grading system. Here's
no
my
grading for the presentation.
Huh?
No grading for the presentation.
This is not the. This is the theory yet. This is the theory. It's coming. This is. I teach you guys 3 classes. This one is called the theory class. Cool. Here's my A all the way to my F. You guys, this is typical what I did with you guys last time too. Academic, honestly, I'm going to pick on Joe. Joe, do not plagiarize with Chad. I don't know how you're going to plagiarize with a project, guys. What I do to help you, because we do not want to reinvent the wheel, I do have the commercial project already designed here. Here's a sample. Make it better. Does that make sense? No need to reinvent the wheel. What I would like you guys to do is not to be a drafter, is to understand why did you drop the receptacle here, not there. Why did you size this panel for this size, not just drop the panel because somebody dropped it? Cool? Understand it. But the project is right here, and it will sit here from now until the end of the semester. Cool? Everybody understand? You have a sample, you have me, and you have Michelle Cooley too to ask. Add, drop. I don't think any one of you will drop. Disability. Anybody disability? Incomplete. I don't like to give an incomplete, guys. So I did not give any complete, but the only thing I can think might go in incomplete if attendance, and I will. Intellectual property statement, don't steal my intellectual property. No, everything that you have you can use, guys. um, Respectful environment, student behavior. I don't think we had anything that we could not handle last year. I tend to be a little bit conservative, so kind of tune it down. And I've been yelling at you sometimes when it goes a little bit up. I will be more than happy to kind of put you down a little bit, kind of tune it down. Student academic assistance. If you guys need help, there is the Elfman Success Center. Technology statement, as long you guys can have your cell phone, you can have whatever you want to do in the classroom, as long as you can give me your full undivided attention as much as you could. You're paying for this. How much you're paying, Kerry? $9,000 for this semester? Close to that? 8,500. So $8,500. It's a lot of money, guys, to spend $8,500 and get nothing out of it. Get the best out of me and all the engineers that's going to come from Michelle Cool Erickson here. It's a lot of money to sit here and play games. But you're adults. I can penalize you if I see you playing game with the 10% that I have classroom engagement. Other than that, you guys are adults. Appropriate behavior, we're fine. Here's how I do the classroom engagement, guys. I like to go over these classroom engagement, cooperating with and helping other students. I give you credit for this. Participating in a classroom discussion with the speakers, students, and instructor. Research new classroom related material, share with the students. Share employment leads, provide constructive criticism of Mr. Security, not just yell at me. Attend NCEL. Not many of you guys go to these NCEL evening classes. In the past, I had students attend it. You can. This is where you can rub elbows with the president of companies if you can. This is a great company to join. Attendance. This is for you, my friend Joe. Unexpected absence, tardies, and leave tardy. That's and leave early. That's where I kind of penalize people a little bit with this. I have computers shut down during lecture. I used to make the students guys shut down their computers. I don't do it anymore because we are in the information age. Though I get really disappointed and upset when I walk around and I'm lecturing and people are playing games. So it'll be an expensive game to play with $9,000, I can tell you. Positive attitude and neat, clean, and organized desk and basket. These are the 10 things that I look when I give you guys 10 out of 10 in your classroom engagement. Attendance, you must be here 95% of the time. Otherwise, you will have an incomplete and you will make up the time. And I don't like to do that because you guys are working or you will be working. So I don't want to see you other than colleagues in the industry. Is that good, Zach, my friend? Okay, the most important thing is how are we going to run this class? Here's how we're going to run this class. This is, Andrew, my friend, is my plan for the whole 12 weeks. Chapter 1, you can see week 1, you guys familiar with my format, right? And if you want to be ahead of us, you can follow this plan. So in week 1, we're doing chapter 1 and 2, and I put them right here, chapter 1 and 2. We're doing classroom introduction. This is what I'm doing now. Your homework is going to start on Mondays of the next week, the week after. Everybody understand? We finished 2 chapters. We're going to average 2 chapters a week. 2 chapters. The homework will be next week. And it goes from chapter 1 all the way to chapter 20. We will have 2 reviews, review 1 and 2, and then you're going to have the final exam, which is chapter 1 through chapter 20. All these chapters are coming from which book? Electrical Wiring Industrial.
We don't have any tests in between my classes.
We don't have what?
We're gonna have a test every couple of weeks, right?
There is a test every couple of weeks. Here is test 1,
Oh,
here is test 2, here is test 3, here is test 4, and here's the final. Right? Everybody can see that? Cool. So that's basically class number 1 that starts at 7:30. Any question, guys, about how the class is going to be run? Everybody understand? Very similar, Kerry, my friend, of how I ran the class in the past. I will ask you guys to do homework, continue to do the homework in teams. Please, I don't correct homework. I will give you the answers. The homework to me is a proof that you read the chapter. I hope. If you read the chapter and answer it to the best of your ability. It's very simple. I can read this one. As a matter of fact, you know what I did this holiday weekend? I reviewed a book for Dilmar. It was close to 450 pages about wind energy. I read that sucker within a week, and I just put 3-4 hours at night. within a week I was done with and reviewing it and write. So reading this book, guys, it would take me, if I want to read it from A to Z, probably a week, a couple of, like 4 hours or 3 hours a night. You can read the whole book, really. It's not really not big, not a whole lot of stuff. You can read it. I will go over the most important stuff, guys, with my lectures, and the answer at the end to the best of your ability. And I do have the answer. We'll share it with you. Everybody understand? I do not correct homework. I collect the proof of reading. We're going to continue, Andrew, the same thing. You and your partner will do odd even. Put them in your team. Any question, guys, about this class? Any question about this class? Okay, do me a favor, flip to the next class. So if you don't mind, so that's basically this one. I'm gonna go, and the lectures, every time I have lectures, guys, I put them under lecture here. Same thing, if you go to the instructor folder, now, Aaron, my friend, we are in 2230, okay? 2230. This is where I put my lectures. 2230, Darren, is very important because all my PDF calculation, this class is calculation, code calculation. All my PDF files are going to be right in here under lecture, okay? So the smartboard is just for me, not for you. Go ahead and open 2230, will you? Open. And let's just go very quick over that soccer too. Okay. Everybody's at 2230. 2230, guys, same information. It's going to be from, Joe, my friend, is going to be from 8:30 to 9:30 this class. So to summarize this class, guys, I selected close to 25 topics in the code that dear to my heart, and I think it should be dear to yours, to do calculation. And these topics range from busway size calculation into motors, generators, sizing branch circuits and feeders and disconnects and overconnection device for PDUs, UPS, busways, generator, HVAC equipment, and among other things. So these are the selected calculation. And you're going to see, like this week, we will have an assignment about generators, motors, and busways. When I say assignment, calculation, or do calculation, how to size a busway. I don't know how many of you guys have done a busway or seen a busway. How do you size a busway? How do you size a generator? When I say a size a busway, the feeder, conductor size, overconnection device, and a disconnect. Okay, so that's basically what this is. The outcome of this class, guys, is code calculation, basically. And here's the 15 things that you guys will learn with your friend Chip, which is course competencies. Number 1, prepare calculation for sizing service entrance conductors, feeders, and branch circuits. When you finish this class, hopefully, you should be able to size any branch circuits in any industrial building, any feeder, and any service. If you don't, ask for a refund. So that's calculation for UPS, ATS, PDUs, panels, service equipment, sizing all these stuff, guys. We're going to go over sizing like we did in the commercial, but a little bit deeper with more equipment.
What is a PDU?
Power distribution units. It's a special PDUs. That's what we're going to go over. They're special panels. We're going to do sizing, guys, sizing electrical load. We're going to do calculation for lighting. We're going to do calculation for security, fire alarm, paging, phone sizing, and master clock, wire sizing. We'll do grounding and bonding, tons of calculation for grounding and bonding. Lightning protection, calculation for lightning protection, how to size the cable, lightning, not lighting. Overconnection device size, and all the electrical, so-called electrical machines calculation, and light sources and luminaires and so forth. So these are the topics that I'll be picking certain topic, guys, and go over it PDF. I do not have a textbook for this class. No textbook for this class. So the only textbook that we're going to be using, guys, is my PowerPoint presentation and an easy code book. Cool? Everybody's good? Okay. Assignments, we're going to do the same thing. If you guys are familiar with that one, we're going to have 4 tests, 12.5% of your final, classroom 10 engagement, and homework 10. Final is going to be 30% for a total of 100. Very typical to all my classes. Here's your A through F grading, right? Am I going too fast on these? Right? So academic honesty, we talked about all this stuff. Classroom engagement is identical to what to do for classroom engagement. Here's where I would like to kind of spend some good time, guys. This is what we're going to be covering in this class. This is how this class is different from the other one. So week one, you're looking at week one right here on the board too. We're going to be doing calculation for busways, motors, and generators. The number that you guys can see here are these NEC code numbers. These are the topics that we're going to do calculation about. I do have the calculation already done. It's a PDF. Go over this in the smart board. Go over a bunch of calculation. The homework. Then you guys are going to have a homework. When I say homework one, you're going to have a one homework about motor, one about generator, and one about busway. Can I have thumbs up, Chad? We understand that? So I'll go over the lecture. Then I ask you to do a homework. I write the homework on the board, right on the spot. So if you can see, we're going to go from panels, transformers, capacitors, all the way. So we have multiple things that we're going to hit a couple of times too. UPS, PDUs, transformers, capacitors. When I repeat the same thing twice, guys, that's because I'm focusing on it from different angle. You're going to see when we do the calculation. So for transformers, we repeat the transformers a bunch of times. Grounding, we're going to do grounding and bonding. MCCs, fire, we have a fire pump here that we're going to be hitting and doing sizing for it, and MCC with fire pump too, spending some time about fire pump. And the test, here's your test number 1, test number 2, test number 3, and test number 4, and the final. So that's the plan for the calculation, the topics that we're going to be covering, as well as the homework and the test. Any comments, guys? Any questions about this? Do you guys like this, everybody? Like we did in the commercial? If you're not going to see, I'm not going to add things to you, and we will go over everything here. So I think it's nice to have a plan, right? That's what I call it, plan. Huh?
Isn't there spring break?
There's a spring break. I'm going to go over it in a second here. You'll see it. There is a spring break. Any comments, guys, about the 2 classes that you're going to do with your friend Chad? Any comments? Any questions? Okay, so these are the 2 classes that you're going to do with your friend Chad. Don't save. Okay, can I have thumbs up that everybody understand that this information is given to you by paper as well as you have a copy of it? All right, I'm going to go switch to the project. The project, guys, Michelle Erickson is coming at 9:30. They will talk about the project. So I'm going to introduce you to the syllabi of the project. Then I'm going to go over a few things here, and there's some changes. After I made a hard copy for you guys, Michelle changed a few things on the schedule, rightfully so, the field trips. So I would like you guys, I don't want to kill more trees and print them. The changes are minimum, not a whole lot. It's just dates and names. So what I'm going to do, I'm going to flash the schedule for you here, and I highlight the changes. And do me a favor, just on your sheet, if you can cross it and write it down when we reach it. Cool? Okay. The project, who am I going to pick? Adam, my friend. Our project is called 2210. That's the class. When you go to 2210, here's what you're going to see. Very, very important things. All the CAD stuff that I gave you guys, it's going to be under CAD. If you go under CAD, these are the CAD files for the industrial project. Cool? Now, if you go and these are, by the way, these are my folder, FYI only. You already have a copy of it. Can I have thumbs up, Chad? The CAD and the Revit that you see in my folder, you guys already have a copy of it in your team folder. It's already set up for you. This is just FYI only, just in case you deleted your stuff, you can come there and copy mine. Can I have thumbs up? Good. Okay. Lectures. If I have any lectures, guys, I have a few of them here. We're going to go over like risers and HVAC equipment. It's going to be here. Lighting. Here's under lighting, we're going to do visual lighting. This project is very interesting because we want you guys to do LEDs. So what we did in the past, with the help with Davis and Associates, we under lighting, please write yourself a note. Under lighting, we have cut sheets about all the fixture that you need. We already have a cut sheets for you. The reason for this, because we decided this project has to be LEDs, and LEDs couple of years ago that was kind of new to us. So we grabbed all to help the students, we grabbed, with help from Davis, we grabbed all the cut sheets for the fixture that I want you to use, and we put them right here. Cool? Very, very important. So here's your cut sheets for the fixtures. It goes even easier than that. The IES files. Here's all the IES files of all the fixtures that we would like you guys to use for this project. The reason why we did now, one second. Now, the reason why we did it because they're LEDs, all of them are LEDs. Now, if you want to go there in Luthon, and you have two options. Either you go to Luthon Visual, open Visual, find them in Visual, or actually you in the library of Visual, or when you open the library, direct yourself to this and load it into the software. From right here, you can load it. Yes, Aaron?
I was just saying, are they in our key folders too? Or
No, these are in my folder.
So they copy it?
Yes, absolutely, absolutely. This is for you to copy and to use. I did not copy these for you. You guys gonna, when you reach lighting, you're gonna go there and copy them. Can I have thumbs up, Chad? Cut sheets and IES files are here. Cool. Visual files. I do have the visual files, guys, for you here. The 3 files, but don't use them. Don't use the visual files because I want to show you how to import, do the same import, export like we did. But these are just FYI only. And again, we'll go over this when we reach it. Design visual criteria, very important. When you come over here, this will give you the location, the catalog number, the height of the area, and the fixture height. This is very, very important when you do lighting calculation. Can I have thumbs up, Chad? It gives you the area in the place. It will give you the catalog number. Everybody knows the catalog number that we're talking about here? Where did it go? We're using this. All the numbers that you're looking at right now is coming from here. Do you guys have every copy? Everybody has a copy, or every team has a copy? So it will tell you where to find these fixtures, as well as the height and the fixture. These are the catalog numbers, FYI only, guys, because we already give it to you. We defeat the purpose, kind of. But the height, the ceiling height, and the height of the fixture is very important when you place your fixtures. Can I have thumbs up, Chad? Because there's so many places and 2-story building, and it confuses you. What's the height of the fixture in this area, Chad? So we group them all together to make it easier. Okay? So that's the second thing about lighting. We'll talk about lighting guidelines in another location. Lightning. We're going to be doing lightning protection for the building, and we have Levi that's going to be coming from lightning, Thompson Lightning. Talk about it. What you see here is the CAD files details about lightning protection. Just remember, there is details. You're going to be copying them as is. Lightning. Load calculation. For load calculation, now Brian, you're going to be doing load calculation this week. This week you're going to be doing load calculation with your friend Chad. Two options. You guys remember how you did the calculation for Chad in the commercial project? You can take your commercial load calculation, copy it, name it industrial, and modify it. I strongly suggest to do that. But because the project is so involved, what I did, guys, for you, I have a PDF file here of the load calculation. I have a PDF file of the load calculation. Let me show you, very important. And I will go over this one too. This is how I would like the calculation to look like. We have the switchgear, receptacle panel, lighting panel, main panel 1, main panel 2, 480 busway, 280 busway, UPS, PDU, emergency panel. These are the panels they're going to size. It's a bigger project. It needs more involved. And right underneath it on this side are the types of the loads already copied for you inside the building, all the mechanical equipment loads. So here's my advice, Kerry. Grab this. Take the commercial project that you guys have done and modify your commercial project by adding the stuff that's not in it. Cool? Everybody understand that there is a layout of a commercial project, an industrial project for you. If you don't have this layout, guys, it will be very hard. I'll talk more about this one as we go through the week. Okay? I just want to make sure that you understand that there is a copy of it. So here's my load calc. Revit. When you go to Revit, in the instructor folder, you have no need to get into Revit or CAD in the instructor folder unless you screw up your folder, then talk to me, especially about Revit. Did you guys hear me? No need for you to go into CAD or Revit in the structure folder. You already have it. This is just where I put my linked file. Power tools for window. This is information later on. Specification. Here's all the specification that you guys are going to put. Remember the spec that was in the commercial? FYI only. What you're going to do is going to copy them into your folder, Kerry. I will give you a hard copy of it later on. But I like to always put them. Yes, it's really the same one. Yeah. UPS and PDUs. Since UPS and PDUs, guys, are special, I have a cut sheet about UPS and PDUs for you here because they're special. We'll talk about these as we go later on. We'll talk about the PDUs and the UPS later on as we go through. I just put a couple of them here for you. Okay, the single most important is Celebi. So let me go open a Celebi. This one, Aaron, my friend, is page 1 in this document. Now we're going, I leave the project to the end because it's more involved. Okay, everybody can see the page 1 in this package, guys. Okay, the project is going to start, guys. The way we're going to do them, like we did in the commercial project, guys, we have 2 lectures in the morning. Afternoon is going to be lab. We're going to have a few field trips and a few speakers. All of them are going to be coming at 9 o'clock. You're going to see later on. They're all going to be coming at 9 o'clock. Yes, sir.
It says on the schedule that Mashad is coming tomorrow. I'm curious if that's a typo.
That's why, no, that's why they changed it after I printed it. What happened, guys, is that's the problem when you're a couple of weeks ahead of the schedule. I printed these guys, and in between, Mashad fully got back and changed certain dates. I'll adjust that one for you. No, they're coming today at 9:30. Okay, now this is your chance, Andrew, my friend, and Darren, and Zach, to really do a much better job than you did in the first project. Completely repetition, guys, completely. And we did it this way intentionally. So all the Revit skills that you did, Jeff, my friend, in the commercial project is going to be repeated in the industrial. With the knowledge that you accumulated. You guys have already done a 12,500 square foot, close to 12,500 square foot commercial building in Revit. Here's another 25,000 square foot, 2-story building, more involved a little bit, but really the concept is identical. So when I say load families, do you think it's going to be different between commercial and industrial? None. Load the families. The only thing are the families are bigger now because we have a switchgear family, and we have a bus duct family, and a PDU family, and a UPS family that we have not used in the past. But all the panel families are identical. Cool? Everybody understand? It's bigger project, but really you guys have, with the knowledge that you have now, when I do lighting calculation, Joe, for the commercial building, we did lighting calculation for the commercial. For the industrial, identical. 2-story building, we're going to run 1 story in one file, another story in another file. Identical, visual. Yeah. Yeah, when they have 2 story, you just take the first story, run it on one file, the second story in a different file. Parking lot, same thing. You guys have done it. Having said that, I will be also walking you, because I know you forgot. I will, and you guys are paying us an arm and a leg. I will be also walking you through every one of them as we go. So you really, Darren, you have no reason not to understand Revit and all the softwares good after you graduate, because we're going to repeat it one more time. Cool? Everybody understand, guys, what we're doing? So everything that you accumulated in knowledge is really going to help you walk right through it. Okay, so this project, 25,000 square foot building, you're going to see in a second. We have a close to I would say 50, well maybe 40, close to 50% of it is a manufacturing floor, bus ducts. So we have bus ducts feeding multiple machines. That's why it's unique.
What kind of manufacturing?
It's supposed to be medical equipment. Medical equipment, yeah. And I'll let Halberg talk about the details of it in a second. Yeah, I mean, Mishad. Okay, I shouldn't have said that. Okay, we're going to be using, guys, the same thing, the NDC code book and the electrical wiring as reference. Here's the software that we're going to be using. You will be using Microsoft Word, Excel, and PowerPoint. Revit 2012. It should be 2012, not 2011. Now here's a catch, huh? Revit 2012. We're going to be using Power Tools for window for system analysis. We're going to be using visual. Is it nice that all these ring a bell to you, right? Before that, most of you guys have never heard of them. Comp check, does that ring a bell, Kerry? Exactly what you guys did. How about visual? Ring a bell, what we did with visual. How about common suite software, the generator sizing? Does it ring a bell? And of course, we'll use internet email and e-voicemail, internet research and all the stuff. That's big deal. I'm going to jump into the most important things is the competencies. The competencies basically summarize it to design, layout, and draft. Power, lighting, low voltage systems. That's what this project is.
So are we going to have separate for HVAC, or is that just?
It's going to be part of, you're going to see it's going to be part of the low voltage system. Our HVAC is going to be part of our low voltage system. Everything that you guys done in the commercial project, you're going to do it twice in the double. That's all. There's addition though. The only addition to it this time is the UPS and PDUs. UPS and PDUs. Really, this is the addition. Okay, so these are all the stuff that you guys are going to lay out and draft, and I have close to 34 things, and I'm not going to go over all of them, guys, that you're supposed, these are the skills that you're supposed to gain. So, but I can summarize it with one thing: draft, layout, and design, fire law, low voltage systems, power and lighting, and also do all the calculation, the code calculation associated with it. Any comments, guys, about what we're going to be doing in this project? Why are we charging you an arm and 2 legs for this? Okay, so that's basically what the assignment is. Here's how I'm going to grade you. This is identical to how I grade you guys in a commercial project. For example, assignment on time, you're going to have 5% of your final grade will be on assignment on time. So if I give you 3 because you did not submit assignment on time, I take notes, guys. I have cut sheets. Giving me all my cut sheets the way I asked you for, you get 5 points out of 100, final grade. Drawing all your Revit is going to be only 40% of your grade, exactly like the commercial. I have generator calculation 5, lighting calculation 5, load calculation 10, Minnesota Energy Code 5, power analysis 5, project schedule 5, specification 5, project binder 5, and presentation 5 for a total of 100. This is how your grade are going to be in this project. Identical, slightly, almost identical to the commercial project with some, I think some of them slightly, the weight is different. Any comments, any questions, guys, about how am I going to be grading them? All your Revit stuff is only 40% of what you do, but very important. We spend a lot of time on that. You can see there's a lot of calculation, a lot of softwares are like load calculation. 10% of your grade is going to be on how to do the load calc for me. So it's a big assignment, 10% out of your final grade. Does that make sense, guys? The gravity, give you the gravity about load calc, for example, or comp check and so forth. Your A's, how is Chad is going to give you an A's is right here the same way. Way at the end, guys, page 8, start the schedule. Page 8, start the schedule. Aaron, this is the same schedule that I have right here. Okay? This is the same schedule that I have over here. So I just put it in my syllabi. Here's my schedule for the whole. So I don't want to walk you through the schedule here. I'm going to walk you through it in a different document, but it's the same schedule. So I'm going to close this. And what I'm going to do, guys, I'm going to give you 5 minutes to stretch, and then I'm going to walk you quick through the schedule. Cool? Let's do 5 minutes. Okay, believe me, it doesn't take much to make a copy, but I don't want to do it. Okay, do me a favor. Grab the single most important thing, guys, is the schedule. And you do me a favor, everything is highlighted in red. Can you change it? So let's start with today. Week 1, my friends, we're going to do Revit setup, E1 through E14. You guys have to do load calculation of project schedule, and it's right here. Plus, I will introduce a project, and Michelle will do that. It's right here, and that's what you're going to do week 1. Any questions about week 1? Everybody's cool with week 1? Okay. Can you guys, the red is no. The red is change. Could you guys do that red? Anything in red, change the date. Okay, week 2. So there's Monday is a change. Monday 0107 today. Week two, which is next week, we're going to do low voltage systems, clock, paging, security, fire alarm, phone, data. This is E9 and E10, Kerry, and you're familiar with my format right now, E9 and E10, right? The only change here is we do have low voltage contractors coming. Matt, can you guys, the red is, Matt is coming and this is his phone number. The reason why I like to change it, maybe somebody will have in touch with him for a project. I think you guys say, yours is say different, right? Bob, yeah. Matt is going to be coming. So again, if you guys can change this one, please, for me and the phone number. Cool? Thumbs up, Chad. Mishad Cooley is coming on Thursday. Mishad Cooley is coming on Thursday. Can you guys see 9 o'clock? All our presentation on 9 o'clock. After my lecture, basically, they'll come and they do present. Okay, Thursday. Do you see the amount of interruption that you guys going to have? We're going to have a lot of interruptions. So we have a speaker on Tuesday and a Thursday. Mishad Cooley, Phil will stop by to check on you how things are going. Okay, so everybody change these two, the red. Let's go to week 3. Am I going too fast? No? Okay. Okay, week 3. Oops, not here, week 3. Week 3, my friends, we have work on power riser diagram, E3.1, low voltage riser, E3.2. So we're going to do the riser for low voltage and power. Does it sound familiar, Darren, when I say risers now? And for low voltage and power? I hope so. You can just submit it. That's exactly what we're going to do, except for the whole building here. Here's the change. We're going to have power distribution. You guys remember Jerry Stanson from last year? The project, he's coming again because we could not get a GE guy. You guys have a GE. Jim Rasmussen have retired, so we couldn't get a GE. So Jerry Stanson from Square D Schneider will be here, and here's his phone number. Okay, and on Thursday also, Thursday the 24th, we're going to go to Boston Scientific. Andrew, that's your neck of the wood. Weaver Lake. What's the name of Maple?
That's right.
Maple Grove. That's a Maple Grove. You will live there. So Maple Grove. We're going to be in Maple Grove, guys. That's right here, Chad. Anybody knows the Boston Scientific big building on Weaver Lake and 94? I think it's 94, right? Yeah. So we're going to be touring this building, guys. The project that you guys are dealing with right now is modeled after this building. So it's really cool to go tour it immediately at the beginning so you can see how things are. It's not as big as that building. That building is hundreds of thousands square feet. Our project is only 25. But it's modeled after. It's a small model of it. Cool? So that's what we're going to do. The way we do, guys, when we have Darren, when we have a field trip, here's my expectation, guys. Like at 9 o'clock here, I would like to leave. I will, what we do is we come here until at least 8 o'clock. I'll do a lecture until 8, and we will leave no later than 8 for Boston Scientific. Because it takes, at least half an hour for me because I'm a slow driver. So we probably will be leaving at 8. I can give ride up to 7 people if you don't want to drive. If you don't want to drive there. After we drive there, guys, coming back to the school is optional. Did you guys hear me? When you go to the field trip, coming back here, I will be here, but coming back is optional in Boston Scientific. I tell you which one is because it's far, and if you want to go home from there or do whatever you want to do, that's fine. But I would like it to be here for the lecture. Cool? So that's where Boston Scientific is going to be. Everybody got the changes, right? January 4th, week 4, 28th to February, we're going to do lighting, which is E5 and E6. Everybody knows why that lighting and power are 2 sheets because there's upper and lower. There's upper and lower level. And we have energy code. Tuesday, we have industrial lighting at, anybody have been at Davis and Associate? Davis and Associate, they are right here. They are probably 20 miles away from us here. Edenbury, yep. Yeah, off 62. Yes. Where did you get that one? You know the area, right? Okay, I'll give you the map as we get closer. We're going to be there. They do a seminar about lighting, guys. Really cool. So we will be there at 9 o'clock and we will not come back. I mean, you can go to work from there. Cool? Huh?
You have to come here first time?
Yeah, we're going to do our lecture though. Ouch. Yeah. Thursday, again, Mishad Kul is coming. Week 5, there is a change in week 5. Week 5, do you guys see in yours, it says that Mishad is coming, right, on Thursday? Can you scratch that? Week 5, the only thing that's happening in week 5 is we have a lightning protection. The only thing that's happening is a lightning protection. It says Doug Franklin is coming, but I believe Eli usually comes, but that's not a big deal for the time being. Okay, everybody got the change in week 5. No, Mishad is not coming. Week 6. Week 6, I believe there is no change. We're going to go to Commons. We're going to do work on power distribution system. That's the receptacles and the panels and the HVAC equipment. Lay them out and circuit them, right? That's what we did. Throw layout, circuit, HVAC equipment, and power equipment in upper and lower. So Adam, here's what you guys are going to work, you and Joe. Joe will take the upper and you will take the lower, or vice versa. Okay, did you guys hear how this project is going to go? 2-story building. The lower, by far, the lower is twice as big as the upper. So, but you guys can choose which one to do. But I would, if my expectation is, Andrew will do the upper or the lower, and Darren, you guys will do the upper or the lower. Change, same thing. Carry you and Aaron. You guys will take one up, one down. Cool. That's for all the power, the lighting, the low voltage, everything. If you load calculation, lighting calculation, everything. They're really split, really nice. 2-story building. Doesn't mean you don't help each other, Zach. I mean, you guys are submitting one project ultimately, but the expectation is it's a bigger project, so it needs 2 people to simultaneously be working on the same thing. And you can't because there's upper and lower. Everybody's okay with that, guys? Okay. So week 6, no changes. We are going to go to Commons Anand tour. Anybody knows where Fridley, Commons plant in Fridley? We go there at 8 o'clock, so you guys don't have art and science in the morning. You don't. So no excuse from art and science. Now, for this particular one, we will meet there. We will meet you guys there. Did you guys hear me? Tuesday. For Tuesday, that's February 12. For that particular one, guys, and I'll tell you, I'll remind you as we get closer. We will meet right there. Cool? And they give you a free lunch and tour of the plant with parallel switch gear. This is in Fridley. If you want to come here and get a ride with me, I'll be here myself. If anybody wants a ride, just swing by here and get a ride with me. Yeah, I don't want to leave before 7. I mean after 7:30 because it gets cutting it close, especially. Yeah, I would like to leave at 7:15. Being the instructor, I like to be there first. You know. So yeah, 7:15 is usually, I'll be there like 20 minutes before everybody's there. It's nice, so we can sign you. So, okay. Week 7, there is a change in week 7. We're going to be working on power distribution and lightning protection for E8 and E11. E11, guys, is a roof. We're going to put lightning spikes, lightning arresters, terminals on the roof. We're going to do EMI tour. Anybody who has no EMI tour right here, 94 in Plymouth, 10 miles away on 94, not 94, 394 in Plymouth. They do switch gears, Kerry. They make switch gears, so you get a chance to stick your hand inside a 4,000 amp switch gear. It's not hot. They're building it. That's a nice thing about this one, Zach, is wherever we go tour, guys, nobody will allow you to touch a switch gear inside of a switch gear. You know, that's prohibited. This is a place where you can stick literally your hand inside a 4,000 amp switch gear, touch the copper, see, have a feel of how the system is meant. Especially Adam, when you're going to spend the rest of your life, my understanding, dealing with this equipment, right? It's nice to understand it. My understanding is you're right. This is your career. You're going to be knucklehead and collecting switch gears at one time. Okay. All right. So that's week where are we here? Week 7. There is a change in week 7. Do you guys use Mishad Kul is coming, right? Can you scratch the Mashad Cooley at 5 o'clock? Scratch that one, please. Week 7. Thank you. Scratch it. All right, so let's go to week 8. In week 8, Allianz office data center right here. Anybody knows where they are? They are literally 5 minutes drive from here on 394. 10 minutes drive. For me, probably 5 for Adam. Speed. So what they do, the nice thing is they have a big data center, and we get to tour the building, their insurance company, and walk into their data center, battery room, and look at major mechanical equipment, guys. Really cool. All these tours, guys, I assume most of you have never seen an operational UPS system in operation. So it's really nice to see him humming and transferring all these data. It makes you appreciate, Aaron, what we do. It's not just a piece of light right above your head. There's a lot of stuff. Okay. Mashad is coming on Thursday. Week 9, my friends, week 9, we're going to have project power system analysis. Now, Joe, do you remember the power system analysis at SKM? We're going to do the same thing. Though we're going to tour Mashad Cooley Erickson. We're touring Mashad Cooley Erickson on Tuesday, guys. We tour their tower, and they give a nice presentation also about SKM power tools for window. Their engineers give you their view on power tools for window. Really good presentation. On the 9th, we do not have Mashad Cooley coming. Can you guys scratch the 9th, the week of the 9th, Thursday 307, scratch that one. Thursday 0307, scratch that one. They're not coming. Cool? All right, who asked about the break? Okay, your break is going to be March 11 through 15, spring break. So you guys are going to have one big break to go to Cancun in Mexico.
That's where the project starts.
Where under drinking starts, underage drinking. Is that what they do there?
Only Cuba now.
Only Cuba. Everybody is.
No, my birthday's on the 17th, so that sucks.
That sucks. Oops. Okay, so that's a break. Everybody get that? Then we jump into week 10. When you say week 10 in the semester, we're going to have a project power system analysis. The same thing. Tuesday, is this a change? Tuesday the 19th. I'm not sure if this is a change or not. And there, okay. Mashad is coming, no change. We do have Dave Karski. Anybody heard of Dave Karski? He's the vice president of Parsons Electric. He will be here. Here.
Or I was gonna say,
Dave Karski.
why does that sound familiar?
Yeah.
Parsons.
Parsons Electric. So Dave Karski from Parsons Electric will be here, guys, talk about estimation project management. Really cool presentation that he put. All right, so Phil is coming on Thursday. Week 11 is finalizing the project in week 11. We have a project management guy here, which you're going to meet today. He will come here and give a 2-hour presentation about project management from an engineering point of view.
No question.
And there are no, number 12, yeah, scratch Thursday in week 12, they're not coming. Thursday, 0328, they're not coming. They depend on us. Okay, week 12, guys, is finalizing the project and presentation. I will send the presentation date as soon as I can. That will be in April, and we'll do the same presentation, and we'll wrap this project. Any questions, any comments, guys, about this? Does that make sense? Did you guys get the corrections, please? Okay, so that's what I wanted to show you. Okay, before Mashad comes, so everybody got the schedule. Can you guys go to the second document? The second thing in the package that I have for you guys, it says ECDM 2210 design building project. This one is right here, Kerry, on the network is a different document right here. This one, no changes on that. No changes. Okay, this is my document. This is how the project is going to be put together. Cool. And so what we're going to, here's the project consists of the following. We're going to do project schedule using Microsoft. Familiar with it, right? We're going to have load calculation, design using Revit, Minnesota Energy Code, lighting calculation, Can you guys see that? Item, power system analysis, generator sizing, specification, cut sheet, presentation, digital copy online of everything that you guys do, and project finder. I need thumbs up, Chad. We fully understand what this project is going to have right in there. Cool? Okay. Requirement. The requirement for designing this project is the NEC code book and the scope that you guys going to see in a second. The scope that comes from Michelle Cool Erickson. That's a requirement. Everybody knows which document am I in? The second page on that. Okay, so that's your requirement. Project schedule. For the project schedule, guys, Microsoft, here's the most important thing here is the dollars that we're going to be giving our electricians. A list of major tasks. Now, who am I going to pick on? Darren, you guys are going to be doing project schedule. Here's what I suggest. Grab the project schedule that you did for the commercial project, copy it, name it industrial, modify it to fit the industrial. Do not invent the wheel. Did you guys hear me? That's how you can do, because these are due on Friday. Load calculation project schedule are due on Friday, this Friday. So what I would do is just copy them and modify them. There's no need to reinvent the wheel. Cool. Project schedule, Microsoft, we got that one. The crews, we have 3 electricians and 6 apprentices. This dollar value is important, guys, when we do the estimation. Okay, sheets. Here's how we're going to make the project, guys. Tomorrow, that's tomorrow's work. When you set up the project, we're going to have sheet 1 is going to say title sheet, right? And it's going to include the list of electrical sheets. Just the name is title sheet. Sheet 2 is going to be symbols. Sheet 3, 1, power riser. 3, 2, low voltage risers. 4, site plan lighting and power. 5 is first floor plan lighting. Second floor plan lighting is going to be 6. First floor plan power is 7. 8 is second floor plan power. And 9 is first floor plan low voltage system. And I listed the bold. Can I get you guys one little thing? The bolded stuff is the name of the sheet. Anything that's not bolded is explanation, right? For example, low voltage system, phone, data, security, fire alarm, data, a clock system, paging. These are the systems. So second floor low voltage, the same thing, 9 and 10. 11 is lightning protection. Lightning protection, not lighting. 12 is panel schedule, equipment schedule, and lighting schedule is going to be number 13, and 14 schedule, 14 is details. Now, Aaron, do you see anything about relay schedule here? This project is not low voltage lighting project. Now, if you want to have, so if you ask me, where's your low voltage lighting control panel, Chad? We're not asking for a low voltage lighting control panel. They will ask about occupancy sensor, but the occupancy sensor, guys, is a standalone power pack right in the building, in the room. It's not attached to anything else. It's a standalone system. Okay? Everybody understand that one? There is no low voltage lighting control panel in this project. If you guys want to add one, be my guest, but there is none.
What about parking lot?
The parking lot is going to have contactors. So what they do is have a box like that there with the contactors inside it, controlled by astronomical clock, standalone. That's how they solve these problems. You don't have to have a lighting control panel, but if you have one, it makes it easier. Okay, any question about the sheets? Everybody understand how the sheets are? All right, so next, Revit drawing setup. Tomorrow, please don't mess with Revit today. Tomorrow, I will walk you through setup E1 through E14. Can I have thumbs up, Chad? We're going to do it tomorrow. Okay. Families. The families that we did are the same families that we did in the commercial project. So you have 3 ways of getting families. Number 1, you're going to go into the instructor folder, and there it says Revit families. You're going to find them there, industrial project. If you couldn't find them there, then go into the Imperial Library that comes with Revit. If you couldn't find them there, ask your friend Chad, because you can go on Revit City online and find them. 99% of what you guys need is in the instructor folder. Really, you don't have to reinvent the wheel. Can I have thumbs up, Chad, about families? Everybody knows what a family is, right? The symbols that we use. Okay, Minnesota Energy Code, my friends. We're going to see the item, how to do Minnesota Energy Code inside and outside. Service and branch calculation. As you do your calculation, whom am I going to pick on? Brian, Do you see that one? It says good design, 10% future growth on the branch circuit and 15 future growth on the panel and feeders. So as you do your load calculation at the end, you're going to add how much on the feeders? Feeders, 15%. So when you do your calc, at the end, when you come up with 55 amps, say, you will multiply it by 1.15 for a future expansion. The branch circuits later on, when you do branch circuits, 10%. It's item number 13 tells you what to do load calculation, guys. Cut sheets. I also list in item number 13 what the cut sheets that you need in a second here. Project presentation, you guys are going to be assigned a project like I did. Here's one thing about the presentation. Whatever you presented in last presentation, you will not present it. You'll present something different. That's kind of, I rotate you. So if you want to pick from now, what you want to do, make sure you pick something that you have not done last time. That's my only requirement. You're going to submit your project for your friend Chad. And when I say submit the project, guys, thank you. Everybody did what I asked you guys. These requirements, like your name, the name of the project, the number of the project, right on the title sheet. So, and all of you did that one. Thank you. That's how you get 5 points just by submitting that information. Okay, here's the tabs for the project. The project, you guys are looking at it right now. This is one big fat project, 2 parts. So you can put it in one big, it's going to be a big one, a big project with information. These are part 1, part 2 of the project. You don't have to do it this way. You can put them in a probably 3.5 to 4 inch binder would be good for this project. We're going to have a project narrative. That's what I'm going over. Project schedule, the drawing, the electrical load, lighting, Minnesota Energy generator, power system analysis specification, cut sheets, and PowerPoint presentation. Does that sound familiar, Darren, with what we've done in the past? Identical.
What is it that like actually fills it up? Is it just the cut sheets and the
There's a lot of cut sheets, yeah, a lot of cut sheets, and there's double the amount of, everything is double, basically what we've done. Yeah, because the building is bigger. So more sheets. Okay, now project binder tab. The tab, guys, under load calculations, this is, you have to pay attention to that one. Here's what I would like you guys, when you do load calculation, what the heck is load calculation, Chad? I want you to do load calculation about these 9 items. And if you go to the load sheet that I showed you, it shows them on the as columns. So at the end of your load calc, I need to know what the size of the switch gear, main switch gear, what's the receptacle panel, lighting panel, mechanical 1, mechanical 2 panels, 480 busway, 208 busway, PDU, UPS load, and emergency panel load. These have to be sized. That's the outcome of the load calculation. Cool. It's easier than you guys would thought. Very much easier than you thought. Under receptacle panel, what do you add? Receptacles. Lighting panel, lighting. Under bus duct 480. In the mechanical equipment, there's equipment that are connected to bus duct 480. You add them up. The biggest, fattest, fluffiest one, you add 25% on it. Done. Really, it looks like a lot of things. It's really not hard. Not hard at all. Energy, Minnesota Energy, guys. Remember the reports that you did for inside, interior, exterior? That's what you're going to do now. Except we have 2-story building, and right, we have 2-story, and we have the outside. Power system analysis. Here's what I would like you guys to do: power system analysis. You remember that one-line diagram, short circuit report, input report, load flow report, coordination curves. For coordination curve for panel, for all the motors 15 or larger. Coordination report for panels, coordination report for 15 horsepower larger, arc flash labels. These are 9 things that we're going to do for short circuit. Generator sizing, same thing. Load size, generator size. Cut sheets. Here's the cut sheets that I would like you guys to do only. Who started doing cut sheets last time without looking at these? Is it you, Aaron? So please, Aaron, this time. Can you see what I'm asking for? All lighting fixture, generator, switchgear panels, transformers, UPS, PDU, busways, fire alarm, and security panels. Okay? Now,
Lighting fixtures are already done.
lighting fixture, thank you. Lighting fixture is already what? Done. It's already in the schedule. So, everybody understand that? Please follow that one. Makes your life easier. PDS, I already have one for you. And PDU and UPS. I really do. Just because they're a new concept.
I just had to cut you for the fire alarm.
Yeah. Not a biggie. For visual.
I've got them already then, so I don't have to do them this time.
Yes, yeah, if you use the same panel. Yeah. Visual lighting. For visual lighting, my friend, I need 9 reports from visual. Everybody can see that, guys? I need first floor, second floor. The same thing, with calculation, without 3D, without calculation, parking lot with and without, first and second statistics and fixture schedule, and parking lot statistics and fixture schedule. You get, this is how you guys get 5 out of 5 in lighting. If you did all the lighting and you did not print this one for me, or you print something with that looks ugly with all the calculation that I didn't ask for calc. So please, this is how it makes your binder looks nice if you follow these directions. If it says calc, put the calc. If it doesn't say calc, don't put the calc. Like my grandpa used to say, you tie the horse to the olive tree that I want you to tie it to, not to the other olive tree. Doesn't matter if the horse is going to eat the olive tree, but you do it wherever you want to tie it to. Crazy, huh? Okay, end. The end. Here's the end. You guys going to submit all this stuff. Any comments, any questions about the project?
So which ones do you want 11 by 17?
Which one I want 11 by 17? All the lighting 11 by 17. I should probably explain that one too. Thank you. All the lighting 11 by 17. Huh? Oh, the last 6 weeks, we're not talking about them yet. The last 6 weeks, what we're going to do, again, I will introduce it as it gets. These are just 12 weeks. The last 6 weeks, guys, here's what you're going to do. You're going to do 2 things. We're going to do McCormick system, McCormick estimating software, and we're going to do, help me here, AccuBid and by hand. We're going to do estimation using McCormick, AccuBid, and by hand for the 3 projects that you guys did with your friend Chad. So we're going to go back to the residential project, take it off, back to the commercial project, take it off, and we will finish the industrial project when we take off on these 3 projects using 3 methods in one of them or all of them. So we're going to do it by hand. The residential, we do the residential by hand. Except when I say by hand, guys, Excel sheet. I have an Excel sheet I give you. Then we jump into the commercial, guys, and we do the commercial using McCormick, and we do the industrial using AccuBid. Cool? Everybody's okay with that? What the plan is for the whole year? I did not say anything about estimation. Didn't give you anything about estimation because I just want to focus on this project. Okay, so that's basically what this project is. I want to remind you of a couple of things. Can you guys see where I'm going to... If you guys go all the way to the last page in this package, please, the last page on this package, you're going to look at the schedule that's called mechanical schedule. Yes. Everybody can see that? Everybody can see the mechanical schedule, the last page. Okay, everybody can see that? These are all the mechanical equipment inside your building. So when Mishad comes in a second, and they're going to say air handling unit right, R1, R2, R3, S1, S2, S3. This is return, this is supply. Air handling units, we have 3 air handling units, guys. Each air handling units have big, fat, fluffy blower. One in the supply and one in the return. So when you say air handling unit R, this is air handling unit 1, the return, and the same thing, this is air handling unit supply. So there are 2 pumps, 2 blowers, one at the beginning, one at the end. As far as you're concerned, you treat them separate anyway. Here's the size, the voltage for them, here's the horsepower. Who's doing division 15 is mechanical, division 16 is electrical, here's the VFDs, and you guys are going to develop a schedule out of this. But these are, it should be, this should be 20, what did we say, 25, 26. We were 20, no, we were 26. What did we do? No, we were 26. 27 is low voltage. Or were we 20? We'll figure that out. Well, I have, what did we, this? I think 26, no, 26. 26 is that.
Trying to confuse you.
Yeah. 26 is electrical, 27 is low voltage, I believe. And 20, I can't remember what 20.
28 is fire.
28 is fire, 27. Well, I'll clarify this one as we get to it, guys. But when it says mechanical is not used. Okay, here's all your mechanical equipment. right underneath it, guys, owner equipment. Can you guys see the owner equipment right here? Owner equipment, very important when Michelle comes in a second when I open it. You're going to see machine number one. It's 2 mil. I have 12 of them, 12 of machine number one. And they're running a 28123 phase and they're sucking 13 amps each. Everybody understand how to read that one? Let's go to machine number 12. It's a welder. I have only one. It's running at 480. It's 3-phase and taking 21 amps. These are all your manufacturing machines. Everybody understand what the owner equipment is? Your manufacturing machines. Yes. When you look at the plan, in a second I'm going to fire the plan. When you look at the plan, you're going to see all these numbers. The only thing you're going to see is numbers. This is how to identify these numbers. Can I get summed up, Chad? We understand that one? This is very important. This one is right at the last sheet. In the last two sheets, guys. The last sheet, here's your, the last piece, or the last sheet is your own equipment. Okay? Everybody understand where they are? All right, so these are my mechanical equipment. The last thing I want to allow Mishad, guys, in a second to talk about it is the scope. Here's how we're going to design this system. And I'm going to let Mishad talk about this one. This is how we're going to design it, power, low voltage, and so forth in a second. So I'm going to stop for a second here. I'm going to go actually open Revit for you. Stay here because I'm going to show you how to open Revit in a second here. We'll leave this one here. Okay, do me a favor, like we have done in the past, Andrew, my friend, before you open anything, go to your Revit. Where's my Revit? Okay, before you open the project, and I would like you guys to do this with me, because Mishad is going to come in a second. Go to open Revit. First, open Revit. We're going to go open your project, show you a few things. So first open Revit, then we're going to open the project. I'll show you where your projects are located. Which team were you last time? Which team you finished with? You were 4, you're 6. It's already set. Everybody's teams are set. So do me a favor, guys. Now we're going to load it. Open your Revit, please. We're not going to do any work. I'm just going to show you how the layout of the building while Mishad is coming. So as they come, and I'm going to show you where your projects are located so you can open it the proper way. Did you guys have any issues with Revit Central File last time? Did you guys? So the reason, please, just do it the way I want to tell you. Instead of double click on it, we never had any issues with it. Let's continue doing it the same way. Okay, your license is like mine is good. Okay. When you open Revit, first, so I'm going to go File Open, or you can go to Open directly. File Open. Okay, Open. All right, when you reach here, you're going to go obviously into all these files. I have a shortcut. If I go to my desktop, here's my shortcut that takes me. You guys still have your shortcut that takes you to your team folder? Right? Everybody should. If you don't, we'll make you one. So go to your shortcut that shoots you all the way to your team folder. So I'm going to click in here. Here's all the teams that you guys are in, right? Now my team, go to your team. My team is number 10. Go to team 1. When you go to team 1, like yours, guys, you're going to see all these folders. Now, Jeff, can you tell me which quarter are we in? Which semester? Number 4. So the reason why I left the fall, the residential commercial, guys, we're going to be using him for, remember, we will be using him for the estimation. So let's go to the spring industrial project. Everybody can see that. Double click on that. When you go there, the way I set it up, all of you guys are the same. You go to the design. Remember how we did? We go to design drawing. By the way, these folders are the ones that you're going to be filling in for it, right? So you're going to go to design drawing. Everybody's there? Before I go there, all your CAD stuff are under CAD. Are we doing this project in CAD? No. What is CAD then? CAD is FYI only, for information only. Can I have thumbs up, Chad? We know that CAD is for information only. Okay. So I'm going to go to Revit. Here's my Revit. When you go to Revit, there are 2 folders. One of them is Sacred Cow shall not be opened unless you ask Chad for. This is the architectural. So because you guys can't, don't go open it. This file, it says Arc Industrial. That's the architectural model. The only one who opens this are the architects. You guys have access to it.
There's no door in the vestibule.
If there's no door in the vestibule, that's exactly. If there's no door in the vestibule, that's where you go there and open it and put a door. Cool? Everybody understand the architectural is for the, when you work in a project, a real project, the architectural is for the architects only to open. They don't want you to go put doors. If there's no door in the vestibule, your job is to call the architects and say, could you please explain why don't they have a door there? There might be a reason, or most likely it's just somebody was sleeping behind the wheel. Okay, so I'm going to go back here one step. Here's where you must be at all times. Electrical. Can you guys see electrical? Just click, don't double click. Click electrical industrial. E Central. Everybody's there? Can you guys see right here? It says create a new local file. Don't detach from Central. Do not detach from Central. So every time you click on it, make sure this is clicked and this is not clicked. Are you guys the same? The ones who are opening it? Okay. So now you have a central file and you create a local for you. So go ahead and after you highlight it, go ahead and open. Now you have just opened override existing. You guys don't probably have existing. And make sure you guys can open it. That's your project. You can simultaneously work on it. So that's basically the project that you're going to be doing. And I'm prepping you for Mishad here. All right, can you guys give me a thumbs up when you're in? Every team? Loading, okay. Okay, everybody can see that? One. All right. Can you guys there? There? It's loading? Okay. Still loading. Because Mishad is going to talk about a few things, guys, you don't have to do that. I'm going to go open a couple of CAD files too, so you don't have to do that. I want to go and open a couple of CAD files in a second here. Okay. You can if you want to. If you go to the CAD files, I'm going to just open the site here, just to show the same thing in CAD, and I'm going to open the first floor and second floor. You don't have to do that. These are FYI only. We're not this time. Everything is linked. You guys are ready to go in Revit. CAD is what? FYI only. Certain information just to look at the project in CAD. So I'm opening this, and I'm going to open the first floor just for Mishad in a second because I'm going to show and second floor. Is it loading? All of us are trying to load. Yeah, all of us are trying to load at the same time. If you guys have Cat 5, plug yourself with a Cat 5, will you? It gets faster. Again, we're not doing. We're killing the network here. Okay. Revit. Okay. Anybody else? Jeff, are you in? Yeah. Okay. All right. Okay. Z enter, E enter. Okay.
strictly for her class. Yeah, like she edited.
I think I went on there and it did say the book was probably.
Enter. Okay. All right. Okay, so all right, so let me, there's my CAD files. Okay, if you guys gonna go take a quick break until Michelle comes, I'm just opening a couple of files for them. And make sure your files are open though.
I don't think it was that much. I don't know, maybe it was actually. I didn't buy it. That's all
Through the program, and he's been working at Mashad Cooley ever since. And as you can see on the schedule, we try to be here from time to time to help answer questions or just kind of discuss some of the issues that you're going through. And it's been myself in the past, probably largely Phil Ortson, who you may have met in the past also. But we're going to pull Nick in and let Nick kind of get more involved with sort of the Mashad representation here at Dunwoody. So you'll see a little bit more of Nick here, I think, this year. So it'd be good for Nick and kind of help continue to support the program. So
Did you mention that he's expert in Revit too?
he is an expert at Revit.
I'm better at AutoCAD, but I'm pretty good at Revit too. So that's what we do all day, every day. So.
But Nick's one of our key guys on our CAD committee. So all of the direction of Mashad Cooley Erickson, whatever we're doing with AutoCAD and helping guide us through our fast transition into Revit. Nick's heavily involved with that, and he's got to become a Revit expert because, at least the way I see it, it looks like each month there's less and less and less AutoCAD work. So if he doesn't become a Revit expert, he'll become the old prop mechanic.
Adapt or die. That's what they say.
So that's that. What we'd like to do this morning, and I'll probably just kind of walk through it mostly, is sort of talk a little bit about this project. You've been given the kind of the scope of the electrical systems, which is a document that I helped create or created and have modified it from time to time over the years. So our approach, or my approach on this is, at this point in time, I'm representing the owner, but then we're also representing whatever architectural requirements exist and also whatever mechanical engineering requirements exist. So we're representing those three elements, and this is a document that we've created that sort of identifies the scope of the project, what the owner requirements are. So that's how we're trying to share and communicate our needs from an owner's perspective to you folks to help put it together. And then you, of course, are the electrical design team putting together the project. It's a project that's industrial in nature. I mean, that was the whole scope of this semester's work, is an industrial project. And Chad originally kind of resourced the technical advisory committee, the TAC committee. And there's not a lot of folks in our TAC committee that do a lot of heavy duty smokestack style industrial projects, heavy manufacturing. Just not a lot of that done in the folks here that have been working with Dunwoody. At Mashad, we got involved with more of the medical manufacturing, so it's clearly industrial, but it's not the heavy duty smokestack stuff, but manufacturing and industrial nonetheless. So the project that created sort of is modeled after, originally it was SciMed Medical, which is now Boston Scientific. And Boston Scientific is a manufacturer for medical devices. The stents is sort of a big thing for Boston Scientific, but I think they're into many other areas I think they're into heart valves and into a lot of the biomedical devices. So this is a medical manufacturing facility. I think the first floor was just under 16,000 square feet. And got one of these old-fashioned pointers here. But the building is a two-story, just under 16,000 square foot on the first floor. As we come into the building, we've sort of got an office, well, there's a vending, waiting, reception area, a couple of private offices, an elevator getting us to the second floor. Then we get into the office space for support. We've created a small data center off in the one corner with a UPS room. And as we walk through, I'm going to point out some things a little bit out of order perhaps, but the load requirements for the computer room is something that we've increased. And you may have to come back as the designer and say, Mr. Architect, the room you allowed for me is too small. There's a possibility that as the load in this room is now wanting to be greater, those UPS may not fit. So you'll have to come back and tell us that you need to make modifications to make those things happen. A couple of restrooms in this facility. Kind of the heart as the industrial project is the manufacturing space itself. And these represent pieces of equipment that we've included. I think we have the owner equipment schedule. So each of these different numbered items represent a piece of manufacturing equipment that would then have defined electrical requirements. And so this is kind of gets to the heart of what you need to support in this manufacturing facility. We've got what over here is the dock area, and then back up to the top part of the sheet. Mechanical equipment space, it'd be a chiller, chilled water pumps, boiler. We threw in a hazardous material room, and Boston Scientific does have some hazardous material spaces, and so this was a chance to get you involved from a code perspective on Class 1, Division 1 activity. So we have that as part of this project. And then I think we have a generator electrical room. We're asking that the generator be an indoor set, so get some experience, working with a large gen set in an indoor environment, along with main electrical service gear. Let's look at the second floor for a second, and I'll walk through a little bit of the narrative. So up at the second floor, we've created a lab environment, so we have some lab benches in this sort of a research area of this project, and also have identified what we call the environmental chambers. So there's controlled experiments that they may that occur within these chambers. So the chambers themselves are sort of pre-manufactured with whatever heating, cooling, environmental controls, and they take a significant power requirement, power hit. Then we've got some HVAC, air handling units that then duct out and feed the manufacturing space. Let's look at the site plan briefly.
Something about that.
I'm sorry, yeah,
Break
we do.
room.
We do have the break room up on second floor. Of course, the elevator that brought us up, and then we did throw in a conference room. I think we have some vending equipment off on this side. So we have power requirements for vending equipment.
And this is the manufacturing floor ceiling.
It's a
That's what we-
two-story space, and so it's a high ceiling in that manufacturing. So keep that in mind as you're looking at the lighting requirements and power distribution requirements for the manufacturing gear. So this is you're right, it is a two-story space. So the ductwork would come in off these air handling units at a high level across that space, duct out. So you have ductwork up there that you're not going to see, but on a real job, you'd have to coordinate with that ductwork with whatever lighting solutions you're coming up with. Question?
The Revit design is different from that one. Is it,
99.9.
well,
In what regard? Because we're flexible.
it shows one big room there, but it shows like 5 or 6 rooms for those.
That's because you're not looking at the right. Don't look at Revit for the time, because the Revit, what you see is depending on what the view they're looking at. So you might see the bottom at the top. So you might see the rooms in the bottom, they're supposed to be in the first floor, shown in the second floor. So because you're not set yet. Yeah, so, and, yeah, when you come, here's the Revit model. But if you go to the second floor right now, because Revit set it up, it looks like this. So don't look at it because of the view that we're looking at.
Sure.
So this is, ignore this one until we start setting up.
Okay.
So, make sense?
Like your generator, is that, we size our first one, you know, for the whole building. Is this gonna be similar or?
Yeah, I'll mention as a walkthrough, but I'll answer that now. Yes, we do want the generator to be sized for the entire building. And then in addition to that, we will be satisfying our life safety requirements off the same generator. So I think on the commercial building, it seems to me that you have battery lights for
Yeah, we did.
egress. We won't have battery lights here. We're going to have the generator, so there'll be some issues that you can need to deal with a generator that's serving optional load and a required life safety load. So I'll talk a little bit about that as I walk through the narrative. Maybe site plan for a second.
Yeah, we mentioned something about the roof here.
Roof.
Too. Yeah,
There is a
little
door.
door, and then there's.
Yep.
Okay, sorry.
So it's a very simple site, parking around it, the main entrance. I think the location that we're anticipating the pad mount transformer, so we can provide the feed to the main electrical service. What do we got here? Telephone service. Okay, yeah. So there will need to be some conduit brought in to bring in connectivity from the service provider for voice and data. So that would be that connection point. And I'll mention again as I go through, but I talk about growth in sizing that service, which of course will affect the generator, and we are showing future expansion. Now, a lot of this is conceptual, and we've done this for a number of years, and we haven't really improved the architectural plan. There's probably some code violations. It's never gone through a true architectural review. So if any of you have any particular knowledge of architectural codes, feel free to mention that some of the things, exiting requirements or whatnot, are non-compliant. We don't mind updating the plan from time to time if we need to make it more correct or more workable.
What's the green on the lower right?
Must be a sign, I think.
Oh, yeah.
Yeah. So I'm not going to, we might refer to plans on some of this stuff. I just want to kind of bounce through what I think are some of the highlights. You've got the narrative to go through in more detail, but, and I've sort of walked through the kinds of rooms that are part of the projects. Under the assumptions, at this point, and this might change if you end up with a lot of time, Chad, but at this point, we're saying that the phone system and the data system design is by the owner. So the owner has their own provider of IT and voice and data cabling and voice and data components. And so all that you folks are worrying about is getting empty conduit to the voice and data locations, getting empty conduit to a main telephone room. That's sort of the way we've been doing things for the last 40 years. But in the last 10 years, consulting firms are getting more involved with the design of the voice and data systems, both the backbones, the copper, the fiber, the connectivity. But I haven't introduced it into this project because, like in our firm, it's sort of a separate group of people that worry about designing that low voltage voice and data system. So, Chad, at this point, we're still keeping that as an owner provided.
They do the layout. They lay out.
They lay it out, but you don't. They're not designing the
It's much involved.
copper cable or
Yeah.
all the interconnect equipment or all of the different distribution rooms that might be involved and all of the different kind of components and punch down blocks and all that.
Yeah.
We're not into making that part of our project at this point because, again, at the Mashat Cooley, when it is part of our firm's responsibility, we have a different systems group that does that design, and they don't know anything about sizing generators or services or power. Their world is low voltage systems. So, but our normal electrical guys do get involved with fire life safety systems. So I have included fire life safety. Our power guys get involved oftentimes. Depends on the project. With some of the core, we might get involved with paging. Some of the old standard systems that have been in buildings forever, but we still kind of make a divide on the voice and data. And we're not requiring our power guys to become experts in voice and data. I mentioned the service to the building. It's kind of looking at 1.4, the 480, 277 volt, 3-phase, 4 wires. So we'll get that service from a pad mount transformer that's located out. And I think we saw that on the site plan. So we'll get that from the utility. It's part of a real project design. As you get your loads, you'd be dealing with Xcel Energy if it's in Xcel territory. You'd be talking to their reps and engineers about your project and trying to coordinate the service sizes and giving them enough information to make sure they got the proper size transformer. So we can answer questions as though we're the power company later on as you get into the design. But we are anticipating that it's the pad mount with the underground service entrance into the building at 480, 277. One thing is we're doing it a little bit different than you did on the commercial project. This is it's not a mission critical data center, but although it does have a small data center computer room in it, we're considering this a sort of a mission critical facility because of the manufacturing. We can't shut the building down for maintenance, and if we do have to maintain things, we need to have quick access to get things maintained and ready to continue on. So you'll learn more about this as you get involved with the, I think we have Square D coming in a few weeks to talk about the switchgear. But I'll just mention again, more at a higher level here. The main gear will be UL 1558, which is a heavier, sort of more robust design of electrical equipment. So it's going to be metal clad. Each power breaker will have a complete metal environment around that breaker. We're going to be calling for each of these breakers to be what we call draw out. So if it's a breaker in the main board, as you shut that one breaker off, you can pull that breaker out. You can remove it, put it on a cart, bring it over and bench test it, and you can do current injection, check, recalibrate, make sure everything's good, do some maintenance on any movable parts, and then put it back in place, and you're good to go. So any maintenance would be quick and keeping this facility online. We use 1558 gear sometimes in hospitals, almost all the time on the main service gear for some of our bigger data centers where you need minimal downtime for repair and maintenance. So Jared will talk more about that 1558 gear, but it's more robust, it takes more room. Power breakers are more sophisticated, and as part of your design, oftentimes since it's a fairly expensive environment, sometimes we'll bring larger blocks of power out of that main switchboard, and then we'll redistribute with other less expensive methods. Because it's expensive real estate. We aren't going to be putting 30 and 60 or even 100 amp breakers if we can in that big gear with the draw out and the metal clad. It's a fairly expensive location for smaller breakers. So we tend to bring larger blocks of power out of that gear into other methods of distribution. I do mention here again that I want that 25% growth. So whoever gets to talk about the load studies, a few months from now, I'll probably ask, show me how you allow for the 25% growth.
Brian,
Okay. Keep that in mind. I want to make sure we're accommodating the future. In item C, we talked about how some of the loads would be fed. We're talking about 277 volt for lighting, so they come out of the 277 40 volt lighting panels. We're talking about transformers to feed 122.8 volt for any of our 122.8 volt needs. Transformers to feed manufacturing. So again, in the manufacturing area, we've got some heavier loads at 120 or 208. So we're going to be looking at some overhead bus duct to support the 122.8 volt loads within that manufacturing space. So you'll need to identify where that bus duct wants to be, and then identify drops to the equipment that are at 120 or 208. And there may be some single phase and maybe some three phase. I think we've tried to mix it up a little bit in that area. Electric chiller is a large block of load that'll come out of that main service switchboard. And then I'm talking about in the manufacturing, we also have some 480 volt equipment that we're looking at, some additional bus duct at 480 to feed the larger equipment within that manufacturing space. You'll need to come up with a solution for smaller collection of mechanical equipment. So you may feed a distribution panel out of the main switchboard that'll feed a collection of mechanical loads in that mechanical equipment load. Post-transition feed parallel to the genset, and what am I saying? The main electric service switch and the breaker for parallel with genset would be electrically operated, controlled by the generator parallel controls. I could just maybe note briefly on that, if I can. Try it.
Give me a second, I'll give you a blank piece of paper.
I'm doing this partly just to try it out. I want to try it. Just looking for
Yeah, 1 second.
drawing your board.
It's nicer, a clean piece for
You had that just teed up right down here at the bottom.
That's, yeah, you can do that. And there's a board for it.
Okay. So somewhere in my building,
Yeah, well,
oh, so this has to be here.
okay, go
So
ahead.
it knows I have the green in my hand. Maybe
It's a bunch of voodoo.
yeah.
Confused.
All right, so this is my generator, and then this will probably work. Somewhere in my building, I have the main distribution switchboard, and that's supposed to be a circuit right there. That's my pad mount transformer from Excel. So I'm bringing my, whatever this works out to be, it should be a significant feed from my transformer into my main gear. And then my genset, I'm bringing into my main gear. And these main breakers would be electrically controlled, and such that kind of oversimplifying, such that they feed all of the big loads that come out of this main gear. Normally, of course, I'm being fed from my transformer from Excel. If power fails, I'm dead. Paralleling gear senses that power has failed. It'll fire up the genset. It trips this breaker open, so I don't backfeed, and when the power comes in, it closes this breaker and come back. So that's how it works in loss of power in kind of a emergency mode. But for maintenance reasons, or for storm avoidance, or for controlling my peak loads on a summer program with Excel, or on a hot summer day, they'd like me to drop load. I can sign up for that peak control program, or I could move my load onto a genset if a severe storm is coming ahead of time. But I want to do that in what I've called a closed transition basis. So to do that in a closed transition basis, if I want to move the load to the genset for storm avoidance or for peak shaving, we would use the paralleling. So there's controls in here. Like the paralleling controls will identify the fact that I want to make this change. It'll fire up the genset. It'll control the essentially the impedance and the sine wave, so that and it will sync that genset with the utility, and it controls it such that when we're within, our sine wave outputs are within a certain window of being in sync, it'll close that breaker onto the utility, and then it still controls even further sort of the impedance of that genset, so that initially when they're closed, the load sort of stays on the utility, but then they can kind of ramp it up and walk the load over, it might take 5-10 seconds we could walk that load onto the genset, and once the load is ramped onto the genset, bingo, it'll open up from the utility, and now I have all of my load on genset, and it was seamless to the downstream loads. They didn't see a hiccup. There was no, gaps in that sine wave. Everything was smooth, and it kept things in full operation. So now I can stay on genset during the storm or during the peak control, and then at the end of that, I can just reverse it and then move the load back to the utility. Now, one thing that I'll mention on this far is, so we've got a big, there's typically an output breaker on the genset as part of the genset, but I mentioned that we're going to deal with our life safety loads. So I'm going to have an ATS. So we do that with an additional breaker off of the genset that feeds my life safety loads. And then in this case, maybe I come up here for my utility, and then this goes to my life safety panels for egress and exit lights. So this is my code required support, and that wiring is separate from my optional building support that I've provided, more from a business perspective. This is my code required. You have to work out details and need to provide a power system and life safety backup system in that manner. I guess for clarity, I should, normally this transfer switch should be on utility, and then my alternate source would be genset. Okay, I've talked a bit already about the emergency power. The go to 1.6, and it just sort of gives kind of a summary, high level of minimally what we're looking for, and we're pretty flexible. This isn't cast in stone. You can be a little creative in placement of outlets or quantities of outlets if you feel it needs to be more. Do more. I think this defines, from an owner's perspective, what we feel is our minimum requirement, and you choose to exceed that. I guess as an owner, I would expect that you'd be able to justify or explain it if you did suggest more. But that's no different than real life. We hear owners' requirements, but sometimes we have to give some feedback by saying, yeah, have you considered this situation where we just don't exceed their requirements without having a discussion and explaining, our position, our perspective. So anyway, that's just some basic, mostly small power receptacle type of placements. 1.7, I do you know, I kind of referred to the schedule. Item B, we mentioned some possible floor outlets out serving island desk locations. Give you a chance to pick out some boxes that have to be set into concrete. Item C is the UPS for our data center that we've talked about, and this will be interesting. This has been bumped up to 150 watts per square foot within that data center environment. So that's how you're going to, and then it's just quite honestly, oftentimes how data centers do get designed, because IT groups really don't know exactly what's going in, but we're sort of tracking a trend of what the load within these data center environments have been, dating back to the early 80s when we were looking at 20 to 25 watts a square foot to a slow growth, and we've done data centers over 200 watts a square foot, and in fact one at 300 watts a square foot. That's getting pretty dense. I mean, that's a lot of heat, but that is the trend within these data centers. So our challenge here is to come up with an infrastructure that'll support 150 watts a square foot. And Chad, I think in my notes I'm going to write a change so that instead of a 120 volt 20 amp circuit, I think I'm going to ask for a 2.8 volt 30 amp, probably a 3-phase whip from the A side and B side. Because if I don't bump up that whip requirement to the rack, there's no way we're going to consume all that power we have stored up in those UPS modules. So I'll send you an email with a change, or you can just change it if you want to two 2.8 volt 3-phase 30 amps circuits within each server cabinet. So,
You guys, can you change that one on yours?
2.8 volt 3-phase 30 amp circuit. Yep, we've got two UPSs, so essentially there'll be what we call power distribution units off of each UPS, and then from the power distribution unit to each of the single cabinet, we'll have an A cord and a B cord. I'm sorry.
Thanks.
One more.
On the previous one, the 150 watts per square foot,
No, the 150 still stands. That change was made. The 150 watt a square foot in size in the UPS still stands. What I'm changing is the circuit size to the cabinet on the floor. Pardon?
Does it need to be converted to volt amps to be able to estimate?
Good question. In our world, computer equipment has a power factor of about 0.98.
Okay.
So we've kind of, it's not the right thing to do, but when we know in our computer floor, at 150 watts a square foot, which when we're talking to owners and IT guys, they don't know what a volt amp is, so they understand watts. But when we translate that into the power on the floor, we know that it's really a volt amp. So in this case, it's splitting hairs, but there is a clear distinction between watts and volt amps, no doubt. But we have a high power factor load, so the reality is it's virtually the same on the floor. There are different power factor issues as you go through the UPS and as you look at your amps coming into the UPS, depending on that power factor of the UPS module. But it's going to affect you more at the UPS than on the floor. You want to do a sketch on why we have a B core per server?
Yeah.
1 second, let me get you the new page.
It's kind of fun.
Very good.
Yeah, so the idea of dual cording computer equipment. So when we talk about servers, it's basically a computer that's about that wide, about that big, about that big. You can fill these racks up with those computers. Those computers inside have a kind of a common DC bus that is connected to two power supplies. So these power supplies are taking in our single phase or 3-phase or whatever power input that you have, and they're all it's all in this bus. So when you lose one of these, the load just shifts up to here, and it's all seamless. So it's sort of like that close transition idea that we talked about earlier. but it's kind of on a smaller scale, and it's happening in your computer. So it's just like your laptop computer. You know, you've got your power supply. There's just two of these hooked into the back.
Yeah, we essentially the same thing as having two jacks in the back for two different power supplies.
Yep, they look very similar.
Unplug one, the other one obviously is carrying double the load. Plug them both in, they split the load.
And the idea with this power supply is going to go back to UPS 1, and this power supply will go back to UPS 2.
And I think we've suggested a power distribution
PDUs.
unit
Oh, sure.
down
Yeah,
in
it's-
between the
Yeah,
UPS
there's going to
and
be PDUs and RPPs. There's some more stuff happening. That's the idea. So you got two
off to
supplies.
your space you got left. Draw a what you and I call a CDU, what
Yeah.
some people call a rack PDU.
So
What you guys I think refer to as a plug strip, but
Yeah.
show how we take that three-phase and how we break it into three segments of
Sure.
2.8 volt, because these are usually
Mhm.
2.8 volt to single phase loads in that rack.
So that was kind of a one line type of drawing. If we switch into maybe kind of a riser diagram, like almost an elevation of this rack. So this rack is going to be, I don't know, 6 feet tall or so, and you've got your computer sitting in here, and then you've got your two power supplies are going to be coming into your plug strip, and your plug strip is typically mounted inside of this rack on each side. You've got side A and side B. These are three-phase, and a lot of the times the computers only need single phase, just like your laptop. So they'll take these plug strips internally will be wired to be able to say, this is phase A, this is phase B, this is phase C. So it'll take your three-phase down into single phase.
Now that's if we have three-phase 4-wire coming in.
Correct.
Then it's broken up into phase A, phase B, phase 3, C, and so it's 120 volt to each plug on each of the servers. And since they have two plugs, one would plug into this side, one would plug into that side.
Yep.
And we used to see three-phase 4-wire quite a bit. What we're seeing more now is 208 volt single phase within this strip. So then all of a sudden what we're seeing is, just the three-phase, no neutral coming in. And we're seeing that more and more. So we're seeing this, we see these little two-pole breakers built into the plug strip somehow. Sometimes you group together something. So all of the outlets in here might be from phase AB, 2.8 volt single phase. All of the little plugs in here could be off of AC. And of course, all the ones over here are off of BC. So I've got 6 or 8 plugs here that are off of BC, and the same for the other 2. And what we're also seeing is they're going to that European C13s and C19s. So I probably won't do this very well, but it has. Let me get this right. I think it's
Not quite that.
kind of like that.
Yeah, that's
Huh?
about right.
So it's not our old NEMA plug. It's the Europeans are winning this battle, and it's the European plug in all the plug strips now. Interesting thing about that European plug, and it's okay in the States, we don't care what that voltage can be anything from 0 to 250 volt, and it's the same plug. Doesn't care. So in the U.S. we'd have to go to a different NEMA plug. To do it the way Nick's had it, these plug strips would have our old-fashioned foam, smiley ground. But now we're doing the Europeans, and we could hook this up to line to neutral to ground and be 120, or we could go hot ground for 2.8, same plug. But this is what we're seeing more and more of within these plug strips is the European C13s for the smaller stuff and the C19s for the bigger stuff. So anyway,
Is there a 16M there? Is there 16M?
the C13 is
One of them
not
is-
much more than 12, I think.
Yeah.
One is 10 and one 16. That's what we use in
Yeah,
Jerusalem. I don't
yeah.
know. 10 and
Yeah,
16.
so that's
These plug strips you can get in hundreds of different configurations and different, because at the end of this plug here, you can do different configurations here depending on what voltage you have, and you can do meters. There's all sorts of things you can do inside of those plug strips. If you want to go cheap, you can go cheap. If you want to go expensive, you can go really expensive.
So as we work with our, and Nick and I, and maybe this is why I talk a little bit more about data centers, Nick and I are in what we call our mission critical group. So most of the projects that Nick and I work on are data centers. So that's kind of our world now at Bashad Cooley. So it's our highest level of interest here.
What we do.
That's what we do. But it's a challenge because you go up and down these rows and rows and rows of computer equipment in these data centers, and some folks just have this mentality. They just start the rocket from the bottom, and then they put in filler panels because our mechanical guys say you got to blank it off because to control air. And well, guess what? They're plugging everything into DC. Then you wonder why I have such a huge phase imbalance back at my PDUs and UPSs. I'm a grossly imbalanced load. So we have to kind of educate our folks that install these servers and plug them in, that either spread it out to use the different phases and the phase relationship, or get a longer cord and plug this guy up here, which then of course as they fill it up, then you got to plug that one down here. So there's a plug management issue in these data centers that we have to pay close attention to. Otherwise, if we have an imbalance, we're stranding power, because then we run into a case where we can't add more to B and C, even though there's lots of capacity on phase A, because as a system, we're going to start tripping breakers. Anyway, spent a little bit of attention on the data center, and that's an area where we've had some changes. So we'll ask for the 3-phase to those internal strips and 30 amp, and we should be able to consume the power that we're delivering at 150 watts a square foot. D on page 4, I think, just as a comment, and I mentioned that on kind of the plan overview, is bus duct. We still think that's probably the most cost-effective way to distribute power down to the equipment below. And I would anticipate the equipment here, just like the equipment at Boston Scientific, it does change. Things come and go, processes change for those folks. So the bus duct gives them a lot of flexibility to change out equipment on the fly and reconfigure or make it higher or lower as needed. So bus duct is a good solution, we think, to feed. And I'll mention it now because that room itself is a key part. You've seen the list of all the tours, and I've actually made contact with all the different people, and we do this every year, and they agree to either give a tour or to invite you folks in for some sort of a class or session. And these are great opportunities to get out in the field to just see what's going on, and we get you down into the bowels of some of these buildings, looking at some major gear, some tours through the buildings. So it's a good opportunity, and hopefully you all can take advantage of that. But the one in particular is the visit to Boston Scientific, again, because that was sort of the foundation of many of the ideas that we put together on this project. It came from the Boston Scientific manufacturing facility. So you'll almost see a space that, yeah, this could be our manufacturing here. I see what you're talking about. So it's a good tour to make sure you don't miss. I mentioned the hazardous areas, Class 1, Division 1. We've just done that to force you to go through some code research on Class 1, Division 1 and how you might apply that. The lab area up on second floor, it's basic research on the lab benches, and I think we call for some G4000, which is a combination power, and then some voice data capability on the other part of that compartment on the plug strip. So flanking each side of the lab bench. Maybe it's not clear, but it's a two-sided lab bench where there's sort of a raised center part. That's what that diagrammatically might represent. So you get your lab bench, and so the plug strip could go on the vertical part of that raised platform with a kind of a small reagent shelf, perhaps. And power connections, but I did already mention to the environmental chambers, and then power, obviously, to all of the mechanical equipment that we're calling for. So there is an owner's equipment list. You've already handed that out, right, Chad?
The what?
The owner's equipment
They
list.
already have.
They
their
have
own
that,
equipment.
and then there's also a mechanical equipment list.
Here's the mechanical, they already have it, here's the mechanical
Okay.
equipment list.
I
And the
don't know.
The owner is at the bottom.
Yeah, it's fairly basic, just giving you the voltages and the power requirements. The thing, and this is pretty typical, I guess, too, let me look at it briefly, but, just the basic unit, power requirements, whether it's a starter or a VFD. Control is similar to our real world, where pretty much most of the control is specified by our mechanical folks in Division 15, and it's in some sort of either an automation or control spec. And that doesn't mean that the electrician might not be involved. Oftentimes, there's conduit needed. There's 120 volt control wires that come out of the mechanical's requirements. So they'll do one of two things. They'll either sub that back to the job electrician, or some mechanical shops have their own internal electrical shop. So there could be two electrical contractors on some of our jobs. One, our base electrical contractor doing all the work we specify, another electrical contractor who may be doing some of the pipe wire and voltage stuff for the mechanical contractor. So we see it both ways. But at this point, in terms of what you're responsible for, we're saying the control wires are by mechanical. And that's pretty typical these days. I don't know if there's anything special we want to do with the VFDs. Probably not at this point.
Yeah, sometimes we see like dual VFDs for redundancy and things like that. For highly critical mechanical equipment, you can actually have a VFD fail and still survive. But.
Lighting. Your lighting's scheduled, Chad.
That's not one.
1.10.
Okay, sorry.
Now we probably will make some modifications to this.
We did, I just told them.
Yeah.
We did, if you guys are okay with it, everything is LEDs.
I'm okay. Yeah,
You're okay
I'd
with
love
it?
to see what you come up with. So
Yeah.
make everything LED.
LEDs,
Yeah,
so.
that'd be
And
interesting.
we cheated a little bit by helping him with IES files. So we do have an IES file for the LEDs that we're using. David's an associate last year helped us put together IES files for all the LEDs inside, outside, and also our cut sheets.
Cool.
So but that would help a little bit.
No, I can see Brayback pushing you to LED. This is still expensive, so
Okay.
come out good.
Yeah.
Selling you an LED.
But there are pros and cons, and I think our lighting group is on the fence in general, because some are still expensive, but it's absolutely a technology that's out there and is only going to get better for sure.
We've used LED on a number of products, nothing 100% yet. I mean, we're still coming up to speed with the TAs, but no. But I'm very curious to see how you come up with LED solutions, and I think, for my take, I'm very open, and in fact I would enjoy seeing multiple solutions. In particular, the manufacturing space. Some of you may want to do clustered LEDs in more of our old Hall of Fame glass fixture that we used to use with metal halide. Some of you may want to do something more linear LED arrays where you're more or less simulating what a fluorescent solution might do. I mean, I'd be really interested to see different LED solutions from different teams.
What Lithonia did, because we went through the exercise last year, is they took the same fixtures that we did here, and they have a family LED panel. The same, it looks exactly the same, except the bulbs inside them are LEDs.
Yeah.
So like VDT, parabolic, recessed fluorescent, you look at it and it looks like but inside it is LEDs. And they named them the same name, even catalog number, and they add LEDs, I can't remember at the end or at the beginning. So they really made it very easy to to do the transition from fluorescent or high intensity discharge into the LEDs. I thought that was really click because you have the same catalog number, but
Yeah.
they add an LED
Yeah.
in front of it.
But again, I'd love to see, and you know, you're gonna be in the heat of the battle here, so you gotta go with what makes sense, but if there's teams that have time to look at other solutions to, you know, then just kind of an obvious LED one, I'd love to see other solutions, if it's possible.
You're right. I think it's nice to do that HIDs to get
Yeah.
into the haptic.
Yep. So no, we'll just make the note that we're expecting LEDs on that deal. Lightning protection, we've got you lined up with someone from Thompson Lightning Protection who'll be coming in talking about lightning protection. I think they've already shared details, so you'll probably have a lot of information even before they get here. But he'll be a great resource to talk about, okay, you know, answer me why we would do this or why would we do that. So he'd be a great resource to really explain kind of high level the ins and outs of lightning protection. So he'll be coming in. The next few, well, paging system, we don't see as many paging systems as we used to, but I'm going to keep it in here just because our basic electrical designers still need to have some awareness and some become familiar with paging systems. So we'll leave it in, but it seems to be a kind of a system that we're seeing less and less with the advent of getting a hold of people with cell phones or with you know, sophisticated desk phones and the likes of that. It's not
Yeah,
as
but
often.
with the manufacturing floor, you need it.
Yeah, and we do call for speakers in that manufacturing floor, so we'll keep it. Clock systems is really something we hardly ever see anymore, but I'm going to keep it in here anyway until they stop making them a centralized clock, a few handful of clocks, just to see what used to be so common in schools and hospitals is a central clock system. Fire alarm, of course, and you'll be meeting with Matt, and he'll be talking about all this low voltage stuff, but particularly on the fire alarm. And I think what he typically does here is approaches this from the standpoint of more or less full coverage, and I'll let him explain, I guess, in more detail. Fire alarm requirements have really backed down over the years as buildings become 100% sprinkled. And if you have a 100% sprinkled building, a lot of the things we used to do with smoke detectors and manual pull stations are no longer required. But I think how Matt from Low Voltage here addresses this is what you do if we had a fully 100% covered building. I believe that's what he does. And that's fine, as long as there's an awareness that you probably won't be doing that in most cases because owners aren't going to want to pay for 100% of smoke detector coverage when they've already paid for a sprinkler system that complies with code and takes away the need to have 100% smoke detector coverage. So on a sprinkled building, there may be critical areas. There may be a smoke detector to close a smoke door. There may be a smoke detector to cause the elevator to go to a recall, or there may be a smoke detector in a duct on an air handling unit. But other than that, we're not protecting the whole space anymore with smoke detectors. But I don't want to take the flare out of Matt's presentation, but I think he's trying to introduce you because there are still times when we do full coverage. Actually, especially in our data center world where we may put in a full detection system. In fact, a complex detection system because we don't have wet sprinklers in the room. You know, we have dry pipe, we have valves that shut the water off. So now we have full detection coverage. That detection system would actually open valves and allow water to come in as a last resort. So, anyway, that'll be coming up pretty quick on your fire alarm and other low voltage systems. 1.5 technology raceways, I think I already mentioned that. Our approach will be you provide the provisions, which might be pipe, wire, there could be some cable ladder to distribute data cables or voice cables out into perhaps even the manufacturing area and office area certainly. But we're not asking you to design the copper cables or fiber optic cables or all of the instrumentation and control components that are part of voice and data. That's an owner provided system. I think that gives my high level, which is what I want to do this morning, along with introducing Nick, because I'm going to have Nick be here oftentimes on the Mashad Cooley visits to just help answer questions and get his insight. And, it's always been a lot of fun. Any questions at this point in time before I turn you loose here?
I don't know if you, I tagged a few security systems for them over the years, which is right in here. Not a whole lot. We borrowed these from the commercial project. We asked them to just add a few security systems right in here. This main security panel
okay.
detector to get them into.
Then, okay, no, that's fine. That's cool.
And then because we
And
were,
Matt should be able to help you with that
Yeah.
when Matt's here.
and we've done it the best. And we added a couple of tamper switches, and because it was nothing, and that one, so they continue doing a tamper switch, and I can pull. I don't know if you have that little document, just addendum.
Okay, it's not in this
It's not in
master.
no, it's not in the master.
Okay. Yeah, send that to me just so we
Yeah.
we have that.
Because they did this one in the commercial project.
Yeah,
It's nice to kind of
Yeah.
keep an eye on the security
Sure.
part and a
Sure.
few other things, and it seems to help solidify the knowledge at least. A horn stroke for the Siamese location and a couple of other things.
well, we've had to keep adding stuff, right? You guys, each year seems to be a little bit
The
more
knowledge
advanced
level
than the previous year. I don't know what's going on, it's your upbringing or what you're eating, I don't know, but we keep having to fill in new stuff each year.
Yeah.
It seemed like we had plenty of challenges, 12 years ago when we first started this thing.
Yeah. They're a really good group. I'm
Good.
not saying that they've been fast in the commercial project, so I anticipate that they really, honestly, you guys did a great job on the commercial project, better than a lot of teams that we had in the past. So they pick on so fast and then they jump in. So I can see that they probably in 11 weeks, maybe 10 weeks, we will be done with a lot of stuff.
I have a question for you in the group, maybe. You're doing this in Revit.
Yep.
Are you going to, is everyone or some having the opportunity to model it in Revit 3D, or is that not? I mean, you get it in 3D anyway, right? If you
Yeah.
do Revit. And I don't know this.
There's
I've never
opportunities to,
plugged
like,
in anything in Revit.
Apply materials and render screenshots and things like
Well, we have done in the past, okay, the bread and the butter of this project is to do the project CAD-wise, like design it first. What we've done, there are teams, when they're finished, they can do modeling the system, and they've done, but it wasn't really a requirement, so to speak,
Yep.
as much as a team that finished and they went into the 3D.
Sure.
But that doesn't mean if everybody's done, we can, I mean, the model is right there, and there's a 3D model into the building right
So
here.
when you put your, what are they, families?
Oh, yeah.
I mean, so
They
they're
can work, yeah.
they're coming in at the right height on 3D. And
They
so you
should.
put-
That's the idea.
You access Mac?
I know, I
That
can't,
model?
I don't think so, I should have brought it.
Well, next time Nick's here, I'll have him bring a model, a project that he did model
Yeah.
in Revit in 3D,
Okay.
and it's pretty cool.
And it's pretty easy inside of Revit to do a lot of that stuff too, so.
And that's what we next when you come. I mean, we
Yeah.
look at the 3D views, and hopefully when we're done with week 10, that will give us, we do
Right.
power analysis to short circuits and like you've done.
Right,
But we really, I anticipate that we'll have some time to really get into the 3D.
Now, having said that, I'm gonna say that my focus is learning design.
Yeah, that's the
As
thing.
much as
Yeah.
Revit can really be fun and informative, but I want you to firstly focus on learning the electrical design aspect and the code and the calculation issues, because it's harder for us to teach theory, it's harder for us to teach design as a new employee. Guys like Nick can help you come up to speed and enhance your CAD skills, as important as they are. But I don't want to see CAD manipulation at the expense of learning the theory and the design. So
And that's the fine line that you have to.
that
always
balance, I'm looking for extremely knowledgeable person in design with CAD skills. If I had to choose, I'd focus on the design knowledge. Obviously the ideal candidate will be excellent in both, but it's a tough one to expect. So again, what I'm looking for is someone who's capturing the design knowledge, experience, and the CAD with the idea that they can become a whiz-bang Revit guru in our shop later. Don't become the CAD guru now at the expense of learning more and more and more about the design.
So the model is right there. It's a two-story building model, and for the most part, the model has been really decent. But we can, they can run anything inside it.
Okay. Cool.
Yeah.
All right.
Any question, guys, for Mashad? Any? So for most of the trips that we're going to be doing, you guys, some of you will be with us.
Sometimes.
Sometimes, yeah.
I go through the Boston Scientific one, and I always go to the Allianz tour.
Okay. Yeah.
That may be the only two that I might get to. I'll probably pull Nick in on some of those.
Yeah. Cummins.
Cummins, what I'd like to do, I don't know that I'll be there, but I usually try to find some of our younger engineers or designers that haven't been to Cummins.
Yeah.
So I try to give them a chance to go. That's a pretty good demonstration.
Yeah.
So we'll usually have one or two folks from our shop that just haven't been there to get a chance to watch that tour.
And the schedule this year is 7:30 to 12:30, so they shifted to
Wow.
synchronize it with the electrical, the other electrical construction. It's easier for scheduling. You know, so
That's fine. Yeah.
so at 12:30 will be done. Any questions for Mashad? I'm sure you guys are excited. Most of them are working, as you probably know, Guy and Nick. So they're excited to finish the project and go be productive, I guess.
Well, and I
More
talked to
productive.
most of you, and there's some that aren't working. I think I talked to those that aren't, and I also spoke. Mike Plumedall does most of our hiring in the electrical group, and I've kind of gotten away from that. Although he and I talk when we're ready to make some decisions. And if he hasn't contacted you, ping him again. He's been swamped over the holidays, and he's gotten a little bit overwhelmed. But we still have the needs, and we've made a couple of full-time hires. But we still clearly have the need. Love to get some part-time help through the course of this year that will transition into full-time come summer. We're looking like, not saying the recession's completely over, but try to explain to anyone in our shop that we're in a recession or the tail end, and not seeing it. We're fairly busy. With, in the peak of the recession, we went from 125 down to 106. The last I saw, I think we're up to 132 or 33 in staff. So staff-wise, we're bigger than we've ever been. And it looks like there's more RFPs out in front of us, requests for proposals, than we've ever seen in the last 3-4 years. So chances are we're only going to get busier. It doesn't look like it's coming anytime quick.
And you guys have a lot of them with grants over the years, right, Guy? I mean, tons of them.
I think we've got 5 just from my class from 2005. I think we had 5.
That was a good year.
That was a good year.
It's like wine. Our 2005 class was a great year.
It's a good vintage. Yeah, we definitely have a lot of fun with you guys running around the shop, so it's good.
Do you know if Michael's gonna make a decision on who's gonna be hiring anytime soon?
I would say, I can't say this week, but if not this week, probably early next week.
Okay, thank you guys. Appreciate it.
Thank you. Well, good luck with it.
Always good.
And we enjoy coming, but I mean, over the years, Chad pretty